Every child works this out eventually. If you dug straight down and kept going, you would come out the other side. It is a good question, and it has an exact answer. To fall through the Earth, you would need a hole 12,742 kilometers long. The deepest hole human beings have ever drilled is 12.2 kilometers. That is not 10% of the way. It is not 1%. It is 1/10 of 1%, and it took 22 years. The hole is in the far north of Russia, on the Kola Peninsula, and it is called the Kola Super Deep Borehole. Drilling began in 1970 and stopped in 1992. At its lowest point, the shaft reaches 12,262 meters, and down there, it is only 23 centimeters wide. They did not stop because they ran out of money, although in the end they did. They stopped because the rock stopped behaving like rock. Geologists had predicted about 100 degrees at that depth. They found 180. At 180 degrees, under that much pressure, granite stops being brittle and begins to flow. The shaft was closing behind the drill. Every meter gained was a meter the planet was quietly taking back. Kola is a real achievement of engineering. It is also a hole that, drawn on a school globe, will be thinner than the paint. So what is actually down there? First, the crust, the part we live on, and the only part we have ever drilled into. It runs from about 5 kilometers thick under the oceans to 70 under a mountain range. Below that, the mantle, solid rock, hot enough to creep like extremely slow treacle, going down for 2,850 kilometers. By volume, that is most of the planet. Then the outer core, 2,260 kilometers of liquid iron and nickel churning. That churning is what generates the magnetic field that holds the solar wind off our atmosphere. And at the center, the inner core, a ball of solid iron about 2,400 kilometers across. It stays solid while being roughly as hot as the surface of the sun, because the pressure will not permit it to be anything else. Add it up, 6,371 kilometers to the middle, and twice that to fall all the way through. Which is where the plan runs into trouble, and the trouble is not the digging. At the bottom of Kola, 12 kilometers down, it is 180 degrees. At the base of the crust, several hundred. At the boundary between mantle and core, around 3,700. And at the center, roughly 5,200 degrees. Tungsten has the highest melting point of any metal on the periodic table. It gives up at 3,422 degrees. Your drill would be a liquid long before you reach the core. But the pressure is the real problem. At the center of the Earth, it is around 360 gigapascals, 3.5 million times the air pressure around you right now. The bottom of the deepest ocean trench is about 1,000 atmospheres, and we treat that as an extreme environment. The center of the Earth is 3,500 times harsher than that. There is no material, and no plausible future material, that holds a tunnel open under those conditions. The hole is not hard to dig. It is impossible to keep. But suppose it existed anyway. Suppose somebody hands you a frictionless, airless, indestructible tunnel straight through the planet, and you step in. The first thing that happens is the thing you expect. You fall. The second thing is stranger. As you go down, gravity gets weaker, because only the mass below you pulls you downward. The shell of planet above you cancels itself out in every direction at once. The deeper you go, the less earth there is beneath your feet. At the exact center, the pull from every side is equal and gravity is zero. You are weightless in the middle of a planet, moving faster than you have ever moved in your life. How fast? For a simplified Earth of even density, about 7.9 kilometers per second, 28,000 kilometers an hour as you pass the center. And then you begin to slow because now the planet is above you, pulling back. You arrive at the far surface with exactly 0 speed to spare. Hang there for an instant and fall back in. The trip takes 42 minutes each way in the simple model. Redo the arithmetic with the real Earth, where the core is far denser than the crust, and it comes out closer to 38. And here is a coincidence that is not one. 84 minutes for the round trip is also almost exactly how long a satellite takes to circle the Earth just above the ground. Falling through a planet and orbiting around it turn out to be the same problem in different clothes. There's one more thing wrong with the tunnel, and it is the planet turning. Standing at the equator, you're already moving sideways at 465 meters per second. Step into the hole, and you keep every bit of that sideways speed. But the walls further down are not moving as fast because they are closer to the axis. Within seconds, you're no longer falling down the middle of the shaft. You're grinding along the side of it. There is exactly one tunnel where this does not happen. Pole to pole, straight down the axis of rotation. Anywhere else, the spin of the Earth turns your fall into a collision. Which brings us to the question everybody actually wants answered. Where would you come out? Almost certainly, water. Land covers about 29% of the surface. But land opposite land is far rarer than that, because the continents are not spread evenly. Only around 15% of land has land on the other side. Dig down from anywhere in the United States, and you surface in the Indian Ocean, far to the southwest of Australia. Dig from most of Europe, and you are somewhere in the South Pacific, hundreds of kilometers from anything at all. The famous exception is Spain and New Zealand. Almost the whole of Spain sits opposite the New Zealand coast, which makes a Spanish child with a spade one of the very few who is ever right. Here is the part one find hardest to sit with. We have never been below the crust. Not once. Not with a drill, not with a probe, not with anything. Every rock any human being has ever held came from the top 12 kilometers of a planet that is 6,371 kilometers deep. The rest has never been touched and never will be. And yet we know it is layered. We know where each boundary sits to within a few kilometers. We know the outer core is liquid and the inner core is solid. We know all of it from earthquakes. Every large earthquake sends waves through the entire planet, and they arrive at instruments on the far side, having been bent, slowed, and reflected by everything they pass through. Collect a few thousand of those, and the interior draws its own picture. Take one example. There are two kinds of seismic wave, one that squeezes the rock along its path, and one that shears it sideways. And a shearing wave cannot travel through a liquid at all. So after a large earthquake, there is a region on the opposite side of the world where the shearing waves simply never arrive. A shadow. The size and the shape of that shadow tell you the size and the shape of the liquid core. Nobody has ever seen the core of the Earth. We worked out it was there by noticing a silence. So, 12,742 kilometers through 5,000 degrees and 3.5 million atmospheres, arriving 42 minutes later in the middle of the Indian Ocean. You cannot dig it. You will never see the inside of this planet. Neither will anyone else, ever. We mapped it anyway from the outside by listening to it ring. This channel takes one number that is impossible to feel and makes it visible. If that is your kind of thing, subscribe. There is a new one every week.